Hello everyone, it's Greg, and today I want to make a presentation. I'm going to present on what is PFAS actually. Like, this is going to cover the semantics, why they're used, where did they come from, and all that good stuff. I'm just realizing I should have probably made, this should have been my first video on PFAS like ever. Instead I made like 3 others on other other fascinating things. But anyways, this should be like video 0, you know. But anyways, getting to it. So PFAS was, well, Teflon is actually the mother of all PFAS. And Teflon is just basically CF2 units are repeated on indefinitely, right? And then there's going to be a CF3 unit at the very end, right? So it's just like carbon and fluorine only, nothing else. And so basically, in 1938, Plunkin at DuPont discovered polytetrafluoroethylene, which is just Teflon, while conducting commercial experiments with chlorofluorocarbon refrigerants. Chlorofluorocarbon refrigerants are what depletes the ozone layer, so we found another pollutant after trying to replace another one. Woo! Love it. But 1938, I don't think the Water Act was even passed or created. I think it was like 1970, 78 or something like that. But in 1951, he actually got an award for it for promoting the comfort, welfare, and happiness of humankind. But I guess that which is kind of absurd to think about it now, but back then Teflon was actually very important because it was put on frying pans, you know, and it was very resistant. It doesn't break down or do anything, you know. It's very heat resistant. You cook on it and you don't get any grease or any terrible stains or anything like that. So it's like, yeah, back then when they didn't even have you know, the Clean Water Act or anything like that, they weren't aware about pollution and stuff. They obviously this was like, you know, pretty amazing, pretty good. But where are PFAS used nowadays? So apparently it's used in nuclear chemistry, which I want to make a video on that. Like, that's kind of cool. I looked into it. It's like, yeah, they're extracting uranium from seawater with a certain type of PFAS, because PFAS is really a family of substances. PFAS stands for perfluoroalkyl substances with an S at the end. So apparently it's used in nuclear chemistry, and that I really want to make a YouTube video about. It's made in adhesive, so like your band-aids and like tape, and other like office supplies, stuff like that. You have it in construction, makeup, but you don't have to be concerned about the makeup or like the band-aids, because like, you know, they only use it in tiny portions. So like, you know, don't have to be too careful about it. Electronics like solar panels, car batteries. I'm very curious if my headphones actually have you know, PFAS in them, but you know, I can probably never figure that out. That's probably trade secret. It's also, but my headphones were made in Germany, so like, you know, probably not. But anyways, yeah, that's also later we're going to talk about Germany a bit. It's also in medicine. We're also going to get back to that later. Firefighting foams. Yeah, it's just kind of used that for different types of fires. Need different, because like, you know, some of them can't be put out with water, and put water on them, they actually get more explosive and dangerous. So you need different types of firefighting foams. It's used in extracting metals, again, uranium, for example, and it's used in, you know, when you have like your microwavable popcorn, you take the bag, pop it in, 30 seconds or whatever. I never made popcorn. And, you know, take it out, eat the popcorn. There's PFAS on the lining of that bag, you know. Again, it's like really oil resistant. It's good for cooking. Like, there are many more uses too. And so, how much exactly? It was estimated to be at like 20 million pounds in 2006, which is just absolutely insane. Don't forget, in like 2002, DuPont lost its legal case in some sort of something, and you know, the PFAS started getting regulated, not regulated, but it was finally brought to attention, like, hey, this stuff is kind of dangerous. But so like after 2002, you know, DuPont probably started thinking, hey, we should like wean off this and like, you know, forget about PFAS. And I think it's either Triple M that said by late 2025 they want to be completely free PFAS free or whatever. I don't know. Um, but that's also a topic for later. But don't forget, like, China is still producing this. So, like, PFAS, like we said, grease, water resistant, like, they're so versatile and everything. Um, and so, on your raincoat, there's probably PFAS on that. Like, if you bought it from China, there's probably PFAS on it. Yeah. There are also atmospheric deposition because don't forget, you could just dump PFAS from like industrial waste, like you know how they release like CO2 and whatever carbon emissions. You could just dump PFAS through the air, and that does atmospheric deposition because of physics. Woo! Um, so you know you have cross contamination between borders and like countries. It's not entirely impossible. I mean, I don't know. I never looked into like a China and America cross contamination. I never looked into it because China's pollution is far different than American pollution, and obviously American. But this kind of brings us to another point. And this was like in a seminar. So last year, there was someone who came and spoke that they were identifying PFAS in New Jersey. So this was from someone from the New Jersey EPA, the Environmental Protection Agency. And so they came to our university, gave a talk and what they found and how they did it and blah, blah, blah. And so they were talking about DuPont, which is in New Jersey. You probably can't see my mouse. I should probably change that. I think DuPont is somewhere here or somewhere South Jersey. I don't know. But basically, they were saying DuPont made this new type of PFAS, type of Gen X, because again, PFAS is a family of chemicals, so you're going to have different generations of it. And so they kind of just released, they didn't properly dispose of it, I guess, and now you just have they had like rings of PFAS around DuPont. And okay, so New Jersey has to deal with that now. They could like a lawsuit or like comply with DuPont, I guess. I don't know what happened to that. But like what was very obvious to me was that there was obvious contamination in Delaware, which is this tiny little place. And the thing about Delaware you have to know, it's that it's like population of 500,000. It is a tiny place, right? Most of the population lives in towns. There's like only 3 major cities. So like obviously DuPont's in the south, so it's contaminating North Delaware. And like North Delaware is only like towns of like 200 people, right, at most. So it's not really practical to like test their groundwater, see if their water is contaminated, and see how their lives are affected by this PFAS bill, especially since like this is New Jersey. This is a New Jersey EPA. That would be the contamination issue is a totally other issue for the Delaware EPA. So it's kind of like pollution between borders is also difficult. What's even more surprising was that I distinctly remember they found a PFAS contamination from here. And again, this was like a totally new PFAS that only they produce. So it's kind of like their fingerprint, So it's like, how do you deal with pollution in Vermont as the New Jersey EPA? And it's like, pollution crossing borders is like just so difficult and hard to talk about. But like, this is not the first time that you had pollution across borders. Oh gosh, I remember there was a case where New Jersey had pollution going into Pennsylvania, I think. Okay, yeah, I do PFAS. I don't do, the other stuff. But it happened in history. PFAS is relatively new, so there's definitely cases of it. But it's only until now that PFAS really had unregulated management. So like, you don't really know how to stress to you how much PFAS there is in the environment. From like the 1940s, let's just assume they were dumping it into the air, right? Or they were like dumping it into the waters in like the Minneapolis River. Let's assume, just guessing. This is from 1940 to 2002 when the first lawsuit was happening, right? Like, maybe they took some environmental precautions, but like 1940s onwards, uncontrolled pollution, there is way too much PFAS in the environment, and we're fine. Okay, I just want to tell you, like, PFAS is really not the end of the world. But anyways, some other sources of PFAS that are really unfortunate is where to start. So basically, right, since PFAS is everywhere. Let's say you have mascara on and you wash your face in the sink. That PFAS goes into the wastewater treatment plant eventually, because it's in the water. It goes to the wastewater treatment plant, and so unfortunately, I do plan to make a video about this later because it was actually a part of my final recently. That concentrations of PFAS actually increase in the wastewater treatment plants because in the end of the day, you're adding chlorine gas, which is really good. No, that's in the drinking water treatment, for drinking water. But here you're adding like other things. You're adding octanol. You're doing UV radiation. You're doing a million things to treat this water just to get things, clean. And but the thing is that there's tons of different types of PFAS, and so you can't measure all of them, right? Like you just can't. So so you might test like two and like see that okay, it's like 1 nanogram per kilogram. Like that's fine. Like that's basically nothing. But suddenly after it goes through the wastewater treatment plant and like the processes, and you take another measurement and you see suddenly it's like 100 nanograms. Like where on earth did that come from? It was probably always there. It just did a reaction and changed properties or like changed to something we could actually measure now. Again, that's a whole other future video. It's actually what got me into environmental chemistry in the first place, wastewater treatment plants with PFAS. Another unfortunate source of PFAS is landfills. So again, like let's say you get a coat, it's totally gets wrecked. You went through a heavy thunderstorm, drenched, ripped apart, whatever. You throw it out, right? Or let's say you have a Teflon coated pan, you see that it's chipping, you throw it out because you don't want Teflon in your body. Okay, fine. So you throw it out into landfill, and eventually, I don't know much about landfills, but basically it's gonna I don't want to say dredge, but it's gonna eventually, liquid is gonna leak down there. You know what I mean? Like it's gonna be disgusting. It's gonna be filthy, yes, and it's gonna also have PFAS. And so are the landfills and wastewater treatment plants responsible for PFAS, even though they did not create it? So these are some really unfortunate sources of PFAS, especially since they don't make a lot of money. These are facilities. They just about break even. There's whole other issues with wastewater treatment plants that, I'll probably talk about in some other video. But yeah, these are very, very unfortunate sources of PFAS, and they have, with more regulation, they're going to have to put up more money to keep up with the regulation that they just simply cannot afford and that they're simply not responsible for. You know what I mean? It's not just, basically, Also, we should talk about bioaccumulation. But basically, I just kind of want to point out that, that plants will take up PFAS from water if it's contaminated with PFAS. They will, some of it, and then either us, let's say it's rice. We don't grow rice in America, but at least I don't think. But we'll eat the rice, right? And now we have some PFAS in us. You could also have animals that maybe carrots would have been a better example. I don't think I don't know how PFAS bioaccumulates in carrots. I'm not sure if it goes into the leaves or it actually stays in the actually root. But let's say the rabbit eats the leaves and there's PFAS in it, because different PFAS have different partitioning. They go into different parts and whatever. And so eventually you're gonna have a fox that eats the rabbit. You're gonna have something that eats the fox, and but that PFAS doesn't change. It doesn't react. It's very stable and sturdy. And eventually it's just going to accumulate into higher life forms that I guess apex predators, I guess. I don't know. That sounds cringy. But yeah, so the PFAS can bioaccumulate, and just a gentle reminder, it's okay. PFAS is everywhere in our world. It is bioaccumulating. We become more and more aware of it as time goes on, and it's fine. In America, what you really should be concerned about is heart disease, because heart disease is the #1 killer. And PFAS is more associated with cancer and liver and kidney issues. And so as long as you eat healthy, that's because PFAS actually passes through your poop. So if you eat fiber, specifically beans, the beans are really good for you. You'll be fine. If you don't eat blood, because again, PFAS partitions everywhere. It's I don't talk about the micelle properties, but basically, this is a whole other video, but how PFAS moves through your body is quite complicated. But day 1, it's pretty much in your blood, and day 3, it's in your stool. I think, at least, again, I'm a chemist, but basically, any PFAS you just got in your body would be in your blood. So if you donate that blood, your body is going to make fresher blood. It's going to dilute the concentration of PFAS, and you effectively offset your burden of PFAS. But anyways, you should donate blood anyways, especially for men, because it's just healthier. And like, it's kind of charity work. I shouldn't say it's like charity work, but people who need blood greatly benefit from donated blood, And also get a Brita filter, because I made a video on this. It's not very good, but basically PFAS can be filtered off. So a Brita filter works. And basically, everything will be fine. Caring for PFAS is a luxury. There's a million other issues in this world that we should be focusing on, So caring for PFAS, it's a noble endeavor, yes, but it's a luxury at the end of the day. There are a million other things to focus on. There's no need to panic about PFAS. There really isn't. Just because they're called forever chemicals, which recently I've been thinking about, maybe I should make a lightning round of PFAS biodegradation tech, because honestly, they are not forever. I don't know how on earth they got that title, because frankly it's ridiculous. But anyways, there is no reason to panic about PFAS. So why do we use PFAS anyways? And so, as I kind of hinted at before, they're very resistant to grease, water, heat, chemicals, anything. They're very, very, very resilient and robust chemicals. And in addition, PFAS stands for perfluoroalkyl substances. It's a family of chemicals. And so you're going to have different chemicals are going to have different properties because of their geometry and the amount of carbon-fluorine bonds or whatever. Everything is going to tiny differences make the biggest things. Another really interesting thing about PFAS is that it's critical micelle concentration. Basically, one thing about certain PFAS is that they actually are soap. And so, as you can imagine, soap mixes with water and oil, and that's why it goes throughout your whole body. But basically, right? And so, but there is a certain concentration of that certain chemical you need for it to actually form that micelle and to be actually soap. And the thing about PFAS is that it needs a tiny, tiny, tiny portion of it to immediately act as a soap. So you basically, any PFAS that you do have in water will behave as soap. And so that's just extremely reliable. And because nothing in chemistry almost ever goes to 100%. Nothing. Absolutely nothing. That's why you always see kills 99% of germs or whatever. It's not because, of lawsuits. It's because it's just factually not true. Nothing ever goes 100%. Absolutely not. So the fact that PFAS is so really efficient at behaving like soap, and the fact that it's chemically resistant, thermally resistant, it just does everything well. Basically, there's no reason not to use it, except for the fact that it causes health concerns, and the fact that it's completely unjust. But and this is kind of just a little bit more technical words about why PFAS is good thermally, good and used in products. I'm not going to talk about it, but yeah, you could read it. And so, okay, so now here we talk about the semantics of PFAS. I really should have done transitions or whatever, but busy week. Basically, it comes down, since PFAS is a family of chemicals, right? What do we actually call PFAS, right? And so you're going to have different scholars are going to say different things, and different companies are going to say different things about what is actually PFAS and what is just not PFAS that we should not be concerned about, or is not a part of our upcoming regulation, right? So looking at Buck et al., this is probably the most famous one. I think it's like cited around 4,000 times or 3,000 times. Yeah, it's probably the most famous definition of PFAS. But highly fluorinated, aliphatic, which means it's just carbon, substances that contain one or more carbon atoms on which all the hydrogen substituents have been replaced with fluorine atoms in such a manner that they contain the perfluoroalkyl minority CN, F, and 2N plus 1, and hyphen dot period. And I'm pretty sure, I don't know because I never talked to semantics about anyone in my lab, but I'm pretty sure this is actually referring to acids. You know, as long as it has an OH and it could be deprotonated. Because the typical formula for like aliphatic substances is CN H2N plus 2. It's so it's kind of like, where's the plus 1 coming from? And it's not like a mistake in like this table that I cited from. I actually looked at Buck et al. And yeah, it's there. It's 2N plus 1 for whatever reason. That might be like a negative charge. I don't know. But I'm pretty sure it's like the end of the quote. But basically, something like this, right, where you have 7 carbons and you have 16 fluorines, you know, that is PFAS technically. But something like this, where, you know, you have a CH2, don't forget, like, each joint and point is basically carbon, right? Because in organic chemistry, we draw so much carbon that, you know, it's far more convenient not to. It's the same with hydrogens. We don't show the hydrogens. And so, like, here's a CH2 unit. Here's another hydrogen hidden. But this is technically not PFAS. So, you know, it's not going to probably be regulated. And then there's another definition. I mean, there's millions of definitions, but another one is PFAS, including perfluorocarbons that contain a perfluoroalkyl minority with 3 or more carbons, or a perfluoroalkyl ether minority with 2 or more carbons. So this kind of includes trifluoroacetic acid right here. And trifluoroacetic acid is kind of interesting to me because, one, I'm writing a grant on it. Two, it's actually not such a big deal in America. That's why I'm writing a grant on it. But in Europe, it's actually like a really, really, really big deal right now. And they're like detecting a lot of trifluoroacetic acid, and like they're kind of, I don't want to say panicking, but like they're very much aware of it and addressing it. The next definition is fluorinated substances that can at least one fully fluorinated methyl or methylene carbon atom. So that's like CH3. Yeah, right here, they say it. And so this is actually kind of concerning because this targets medicine. Like, I'm not going to tell you like how they work. Like, that's actually pure biochemistry stuff, you know, and I'm a chemist. Analytical environmental chemist, right? Undergraduate also. But like, these medicines have this CH3 unit on it. CF3, sorry. And so this is technically PFAS. However, one thing I will say about all of this semantics, right, is that the EPA, which regulates chemicals, cannot target entire families of chemicals, right? They target very specific chemicals within that large family. So they might not even target any of the stuff I'm showing you. Well, maybe they'll target trifluoroacetic acid because, again, Europe is a big issue. But they'll probably never target this stuff, you know what I mean? Because EPA is designed in a way to target one chemical at a time. And that's kind of also another setback because like there's so many different types of PFAS, and it's like the EPA doesn't have that much manpower, money, and don't forget it's like all legal stuff too, you know, and it's like a whole lot of legality stuff. We'll talk about the legality stuff later, that are just not in favor of the EPA, or like that kind of made a loophole for PFAS specifically, I guess. Well, it's not really a loophole, but anyways, later. And so now I just want to talk about PFAS contamination sites. And yeah, it's pretty bad. As you can see, New Jersey, where, hello, this is supposed to be New Jersey, where's Delaware? But yeah, it's pretty bad. But again, it's a luxury, and this is just drinking water above the proposed limit. You know, that means like when you have wastewater treatment plants, you know, they let their water go into a river, or I think it's in California, they directly dump it into drinking water treatment plants, and there they add the chlorine, which is, which really cleans the water up very nicely and like keeps it nice and clean until it gets to your sink and you drink it. But yeah, so this is drinking water treatment plants. They're actually detecting the PFAS higher, right? And so, as you can see, that's all the blue dots, which is kind of scary. I'm even surprised Idaho has an issue. That's one I'm very surprised. I think Idaho has probably the cleanest water. North Dakota is doing lovely as always. Arkansas, that's kind of... I never even thought about Arkansas. Wow, okay. But yeah, look at New Jersey. Holy hell, it's a super fun site in its own right. That's incredible. Oh gosh, I think there's like 40 Superfund sites in New Jersey alone. Yeah, I don't know. It's crazy. But yeah. Gosh. Next one, Europe. Woo! Yeah, you see why it's a big issue. I don't know how reliable this website is because again, this is a Greek website. And they were also making a big deal how they got this data after 2 years of emailing a professor, and was like, I'm thinking like, the professor probably thought you were spam and didn't respond for you for 2 years. That's why. But anyways, well, I think this is Sweden. I think, I don't know. But yeah, no, this is Denmark. Or is this Denmark? Oh gosh, I forgot already. But yeah, American Center. What I'm really surprised about is France actually down here. Mainly because I think they have a lot of nuclear chemistry in the south of France, and we saw that PFAS can be used for nuclear chemistry, which is kind of surprising that this place is so clean. But I guess it also makes sense that Paris is also like super contaminated because like the rest of France is kind of elevated to relative to Paris, so it's like kind of like Paris is like kind of like a dent kind of, and so all the pollution kind of just sinks into Paris. So that's not so surprising, but I'm kind of surprised there's not more PFAS contamination here. Here, I'm pretty sure there's like leather processing or something like that, but yeah, that's like Florence and Milan, I think. But yeah, I'm pretty sure this is Denmark. Oof. But yeah, again, the links are in the description. Just reference the slide number if you actually want to play with this site and like zoom in and all that fun stuff. Next one is Canada, and I really don't like how they did it. I should have probably looked around for a better site, but I just don't care enough. Again, I'm just too busy. Applying for grad school and writing a grant is life training. But anyways, but basically, it's not nearly as bad, Again, this doesn't have unlike the other two sites, websites that I reported, they don't show like concentrations with like more color intensities or like stuff like that. And so it's kind of difficult to get a gauge about how bad each scenario is. But it's not so bad. It doesn't seem terrible. But again, I have no idea about the concentrations, and I almost never read any papers from Canada about PFAS contamination. Now that I think about it, I read a few, but anyways. Again, I don't know how reliable this website is. I did not like navigating through it. Yeah, I wish they had a day-night mode or whatever, because it's just frankly annoying. But anyways, so who's paying for this? This is again about the legality stuff. I highly recommend this article. It was like really good. I don't like what they did. I mean, maybe it's because I'm a scientist, and like at the end of an article, we don't say any biases, but like this argument was very much. This paper was very much an argument for giving the EPA more power and money and whatever, which was like, oof, never saw that in science. Even though everyone believes it, no one will ever say that in a paper. But anyway, so like I said before, PFAS comes from human society, right? You have landfills and wastewater treatment plants that are technically creating PFAS, right? They're the ones who are held responsible for it, right? Which is just unfair because they're not actually using it, right? They're not actually making it for profit, unlike these other companies that are using it for like adhesives, mining, firefighting, or whatever. And so it's like really not fair for them because don't forget they're already breaking even, like barely. Usually they're not even. But I mean, yeah, they kind of are breaking even. But anyways, depends place to place. But then like who's supposed to pay for it? and this is a quote directly from this paper. Again, I highly recommend it. U.S. residents who have to pay with their own PFAS poisoning now have their tax dollars allocated to fixing PFAS pollution, again, which they didn't even cause in the first place. So yeah, it's very unfair and unjust. It's not very fun. So obviously, the solution is to get these companies that actually make the PFAS to pay for it, which is much more harder said than done. You really have to, like, metaphorically twist their arm, make them cry uncle, and all that fun stuff, because again, it's legal stuff, you know? It's judges, a lot of back and forth, a lot of time, a lot of discussion, you know? And it's, it's not my field, but again, I really recommend this source. Again, it's going to be in the description. It really talks about it all. It was shockingly readable. I'm a chemist, so I kind of got, like, especially that I work with PFAS, so I got kind of used to the PFAS acronyms and, like, like EPA and stuff like that. So you might struggle a bit with that in first place, but if you have, like, a notepad, and look at that and, like, keep the acronyms there, you'll be fine. And the paper also does a really good job of, like, repeating what the acronyms stand for, so it's really fun. It's a really good source. I highly recommend it. And here are some more other websites. ITCR website, I gotta give them a shout out. They criticized green chemistry. It was not the best criticism, at least I don't think so, but it was a criticism and I like it. I stand for it. Oh gosh, yeah, I hate green chemistry. But yeah, here's the works cited. Again, links in the description. And yeah, thank you for watching and have a good day. Bye bye.